Om Swastiastu. My name is Putu Januartha Prayoga Putra. Today I'm gonna have a presentation about testing and inspection of metal, the quest for a quality. And then next, for the main reference I use is Metallurgi for the non-metallurgists, the second edition. Next, the context of this chapter. Context of this chapter 7. Chapter 7 is have like seven chapters, and first is metallography, hardness testing, tensile testing, trench toughness, impact testing, vita guide testing, non-destructive testing. The next, first, metallography. Metallography is the scientific discipline of examining and determining the continuation and the underlying structure of or spatial relationship between the continuation in material and alloys. The examination of the sector may be done over a wide range of large scale of magnification levels. Range for a visual or low magnification is 20 times. Examining to magnification over a thousand times with electron microscope. Some history: the critical factor of the light microscopy of the metal is a surface preparation of the specimen. This is the basic insight made by the father of metallurgy, Henry Clifton Sorby, who in 1863 was the first person to examine properly polished and chemically attached metals example under the microscope. With the application of microscopy occurred more than 2 centuries later than the initial application of the biology microscope, because the microscopy of metal requires careful preparation of the surface. The next, microscoping was one also used to reveal the sector of polished materials, such as a famous Wilkman's Spencer structure discovery in the 88 by Count Alois von Wilkman's Station, a geologist of Museum curator in Vienna, and his co-worker Carl von Scherbius. They studied various meteorites and thought his effort revealed the outstanding crystalline patterns in the Albedo iron meteorite that fell in 1751. An excellent example of their work is shown in Picture 7.1. Picture 7.1, example of that they show. This type of structure, which appear in many alloys, is now referred to as Wilmation structure. From this beginning, the importance of specimen preparation remains central, but today many deficiencies arise when proper preparation methods are bypassed. False structure or artificial can arise from the preparation in many ways. In particularly, just maroon cylinder, like picture 7.1. TM2301 was the first to realize the artifact were sometime being offset due to the presence of a layer of destruct metal formed during the early stage of the surface preparation and not during polish itself. Next, the deformation that the two microscopic we see only when the discovered layer was removed, and he devised a method for doing this task, the application of alternate etching and polishing step, like picture 7.3. Next, in alternate inspection, regularly shaped specimens are sometimes examined in the mounted condition. However, the most specimens are mounted in the picture 7.4 for convention because they are often small or oddly shaped. Specimen can be mounted in the mold with cold mounting polymers such as acrylic, polyesters, or epoxy. Alternatively, some specimens may be mounted with polymer using a heat and press mold. This is picture 7.5, 7.4. Next, 7.2. Hardness testing. Hardness, as the term is used in the industry, may be defined as the ability of the material to resist permanent invasion of or deformation when in contact with an inductant under load. Generally, a hardness test consists of pressing an inductor of known geometry and chemical properties into the test material. The hardness of the material is qualified using one of our variety of scales that is directly or indirectly indexes the contact pressure involved in deforming the test surface. Hardness tests are no longer limited to metal, and the tool and products correctly available cover a vast range of material including polymers, elastomers, discs, thin films, some conductors, and ceramics. Hardness measurement as applied to specific classes of material convey different fundamental aspects of those materials. Next, hardness tests may be classified according to various criteria, such as the type in the indentation measure performed, area or depth, magnitude of the indentation load, nature of the test, such as EA, static, dynamic, or test. For example, the measurement of the indentation area is used in the various figures and knob hardness test. In contrast, indentation depth is measured during Rockwell hardness test. Hardness test may also be classified based on the magnitude of the interconditional load. These tests are often referred as macro hardness tests with industrial load more than 1 kg per night. Micro tests with industrial less than 1 kg F. Non-hardness tests with additional load that may be as small as 0.1 meter-newton or 10⁻⁴ newtons with depth measurement in the 2 Nm range. Macro hardness tests are commonly performed as an integral part of quality assured production in the microhardness test. Loads exceeds 1 kilogram or 2.2 lb, and the resulting in the interaction is invisible of naked eye. Tests in this category including the Brinell, Rockwell superficial, and Vickers heavily load test. Next. Brinell test. The setup for the Brinell test is shown in the figure 7.5a. 7.5a. The indication of the measured in millimeters are showing in the picture 7.5b. This is 7.5b. A hardness steel of carbonate ball 10 millimeters or 0.5 inch in diameter is normally used. The force applied is 3000 kg or 6.6 6,600 lb or less, depending on the material. The diameter of the spatial impression is measured with the microscope to an accuracy of 0.05 mm or 0.002 inch. Next. The Rockwell hardness test come in the two variants, regular Rockwell and superficial Rockwell. The superficial Rockwell test applies a higher load than the regular Rockwell test and has a special and barrier indenter that is more precious than the regular barrier indenter. The destination product by both light and heavy load are showing in the pictures 7.6a and b, respectively. 7.6a and b. Next. In the regular Rockwell test, cone sharp diamond indenters and hardened steel ball indenters are used. The diamond corner indenter showing in the picture 7 is called a Breller indenter. Balls are usually 1.6 mm or 0.063 inch in diameter. Load applied by either type of the indenter are 150, 160 kg each. The abbreviation industry of the force applied in kilograms. Microhardness test. In microhardness testing, loads are less than 1 kg each, and indentation can be seen only with the aid of microscope, knob, and figures. Low load tests are in this category. Indented use and the indentation they make are compared in figure 7.8. Figures indenter. The figures indenter is square base diamond pyramid, like picture 7.6, 7.8a, 7.8. The applied load force in the general 1 kg F or less. A typical impression also is shown. Test specimen must have a polished metallographic surface for viewing and measuring with a microscope at a magnification of application 200 to 400. The specimen is placed in fixture and the microscope is focused on the area S of interest. Intent tests, as in other hardness tests, and higher number the hardness material. Micro-hardness test can be used to assess the hardness of continuous observer in a microstructure for the area of the intention. Picture 7.9 is the example showing figures in the session product with 50 kg force GF load. Next, hardness conventional because the testing labs are often limited in the type of equipment they have available. These limits are the type of the testing that they can perform. For the reason, and possibly several other, is it often necessary to take the grading acquired in one hardness test and convert into a value that will be obtained in a different type of hardness test, because all of the tests in common usually they are not based on the same type of measurements. It is not surprising to the universally recognized and accept hardness conventional relationship have not been developed. Hardness conventional instead are based on the temporary relationships that are defined by conventional table limit the specific categories of material. That is different comparison tables are requirement for material with greatly different elastic modeling or with different structure hardening capacities. The most reliability hardness conventional data currently exists in species for steel. See that appendix of the book several standards for the hardness conventional axis such as SAA's G470 hardness test and hardness conventional graph 7.4. ASO 4964 hardness conventional steel graph 75 7.5. ASTM E140 standard hardness conventional table for the material graph 7.6. Conventional table ASTM E140 including those for nickel of and high nickel alloy, contract brass, outer-stick stainless steel plate and copper. Next, 7.3 Tensile testing. The conventional measures of ductility that are obtained from the tensile test are engineering strength at fracture, as we usually call it, the elongation, and the produce in the area at fracture elongation and production in area usually are expressed as percentage. Both are tested properly are abandoned after fracture by putting the specimen back together and taking or measurement in the final large LF and using the diameter measure a fracture of the calculator that final fragment cross sectional area F EHV LF minus LO per LO LA is AO minus AF per AO because an applied fraction of the plastic deformation will be contained in the micro region of the statement specimen. The value is the EV will depend on the gauge slate LO over which the measurement was taken. The smaller the gauge slate, the greater the combination of the overall elevation from the neckline again, and the higher value of the F thermometer when the responding value of the first stage elimination, the gauge strength should always be equal. Testing mechanism, mechanical testing mechanisms have been commercially available since the late 1880s and have evolved from purely mechanical machines such as the proper little giant heart dragon tessel test of the Danish Ocean, Tirta 1900, picture 7.10. Today, a super-specialized machine with enters electromechanical gear or sulfur hydraulic drive to perform rapid and precise measurement of load and discipline. Their value can be used to calculate properties such as change, strain, and declination, lead strength module of the electricity and the other mechanical properties. Next, the pros of the selection of the typical gear-driven system is shown in the picture 7.11. This is 7.11 picture. The screws are rotated by the variable control motor and driven in the movable crosshead up and down, up or down. This mentioned can be loaded the specimen in the bare tension or the compression, depending on how the specimen is functional and tested. Screw-driven testing mechanics correctly used of the either 1 minus 2 minus or 4 screw design. Eliminated twist in the specimen from the rotation of the screw is multiple screw system. One screw has the right hand threaded and the other right hand threaded. Next, servo hydraulic system has a hydraulic pump and servo hydraulic pump that move on as actuator piston atomic oil valve that actuator piston attached to an end the specimen. The dimension of the actuator piston can be controlled in the both direction to condition tension, compression, or cycling phase. Several hydraulic systems have the capabilities of testing the form allow as a 45 x 10 minus 11 millimeter per second or 1.8 x 10 minus 9 in h per h to 30 millimeter per h or 1200 in h or less. The actually useful rate or any particular system depending on the size of actuator, the flow rating, and the servo and the noise level system electronics. Next, the use of proper grip and practice for the testing material in the testing critical is obtaining meaningful result. Trial and error often will solve and practical problem in proper gripping in the test specimen. Various types in the gripping are used specimen for the potential testing are often produced with the thermal and picture 7.38 that are screwed into the front strip are in the mechanical case. The advantage of the thermal specimen is that they cannot slip inside the grip during testing. Slipping can sometimes be an issue with E-type gripping, but the picture 7.14 load capacitors with reference from the other 4 kilogram force or 10 lb force to 2000 kilogram force or 100,000 lb force or more. Next, 7.4 fracture toughness. Plastic deformation in the pressure material are caused by the pressure of the sheet, that actually meaning their strength or of real engineering material are often several order of the mechanism lower than tripressure cell strain of perfection defect free crystal structures. This is discrepancy between stability and deformation occurs because defect is in the crystal structure current. Expansion begins to the move when the shear stress access in the concept value. A similar analysis can be performed for the critical stress QC requirement to perform adjustment atomic plan by breaking the atomic order to affect different materials. The resulting critical stress is given by QC. It's E point per 2 p. There's E is the plastic model as a sample present value of the E. It's 200 GPE or 30x 106 I into E3AQ 7.3 for the still allowing result of the metal critical stress of G33 3003 GPE or 4.8 x 106 base I. The actual measure texture strength of the steel alloy performs are typically several orders of magnitude lower than this. Is in the defect such a crack where it's growing in the material when the amount of plastic strain energy per unit value will be reduced because the applied load cannot be supported across the base or the fracture surface. Consider picture 7.15. There is material continuum of the problem thickness crack in the length 2E and illustrated with a crack outward-oriented perpendicular to the direction of the application stress. Although the stress result in the original crack can be acquired and completely under discussion. To good operation will be set area in the fracture pressure region where in the stress acceptably fall to zero due to the presence in the crack is this region. The surface amount of the plastic strain energy can be stored the value V or the region simply the area of the ellipse that is dispensed in the picture 7.50 multiplied by the thickness of the material. Find that V is 2PA 2B, where B is the material thickness that totally among the plastic strain energy UAL that will be the release produced upon information fractal is square the product of next method propagated. Of course, when the stress factor key equivalent excess critical stress factor KLC, which given KLC is EGC 1.2. Later, the stress of the fracture machine KLC reference fracture thickness. New material value is greater toughness for the selection of the group material showing the table 7.1. This is 7.1 table. As a classic example, 112 is the southern fracture of the S certainly figure 7.16. She was removed at the Sitting Island in Oregon. It's a calm weather on the January 16, 1940. Shortly after returning from the shield trial when the present ambient temperature had fallen to minus 15 degrees Celsius without any warning, with a noise that was audibly of the release of melt that suddenly crackled almost in the crowd, just like the super texture that cracked in the well in the pool and settled down to the port starboard side almost of the keel, which itself ruptured. The ship Januartha opened and of the water at so with a bow and the sides of the bottom of the river. The only recent section in the pool is unbroken was the seat of the bottom plate, and the dramatically catastrophic failure into illustration by this example can be effective in lesson reaching the method of LAFM. Next, it should be noticed that KLC is always only concerned of the well defined material properly under plane stretch loading conditions when the material possesses circular thickness like a picture 7.17. There is also geometry factor that should be applied in this question, but thus a value is constant to 1 in applied to the calculation calculating is picture 7.17. Next, non-material plastics shown normally from interaction of a fragmented non-material place under solid stress. The local stress has sharp crack in the plastic material is growing by Q locals. It's a Q plus Q or A per air 2 air 1 per 2. That is quite a place stress in the crack large which R is a variation of the crack tip like in the picture 718. In the examiner radius that plastic can be approached by setting the local stress for the varying stress of the material. This is by setting Q local H QE. This is 7.18 picture. Next. That was tested with a difference of pressure elastics for turn mechanism. Engineers now realizing that design and structure of the mechanism can be no longer under all conditions be based on the plasticity of the yardstick. Produced test has been developed on the meaning that fracture toughness of the material can be used as testing the condition on the specimen present Precisely 5 different standard measurement geometries are in the ASTM A399 grabbed in the 7.9, but the almost correct factors are conditions there are only noticed when or impact test in specimen like picture 7.19. Testing is not calculation. On the screw drive 1 or sulfur hydraulic mechanical lower specimen describable rate of the mentioned experiment order taken during days. This is the point 90. Picture next. The proof development of the zinc of the stable material is anisotropy ASTM standard the following 6 of orientations. L minus S, L minus T, L S minus L, S minus T, T minus L, that's N, T minus S. As the shown in the picture 7.20, the small slight relation of direction of the plate load on the second level related to the direction of the crack drawing in the designing of the structure toughness condition of the foundation is very important because different can be shown in the wide different factor value. Next. Point 1. 7.5 impact factor. In the impact test, in the specimen object in the dynamic, so loading in the variable operation of the material to the rate change in load, such as in the experienced by an axle shaft when the occurs in the obstructor hole. The standard impact vessel and the operation of the listening pressure 7.21 7.1 when a specimen is placed in the part of the stringing volume in the volume must be an or the factor of specimen if it is continuous its RERC is equal to 7.21. Next, the two most common factors to testing sulfate and the azote test. They are different mainly in their manner in the specimen, which specimens are highly of and broken. Picture 7.22. The carbohydrate pressure is done specimen over a range of temperature because some material may exhibit of relation to the transition at a low temperature. For example, only a small amount of the energy need factor of low carbon steel specimen or low at low temperature. This is 7.2 picture. 7.6 Fahrenheit testing. In the general, Fahrenheit normally consists of the crack functional phase of the crack and propagation phase. This is separation in the final process into direction of propagation. Shape has been important operation in the sample of the concentration version. Fahrenheit, which is for the equal to the laboratory. There's type of organization testing method are usually first is high cycle, infinite life, traction control, testing, low cycles, infinity life, track control, fatigue testing, crack growing or testing based on the factor mechanic concept and stress K at the crack tip. Their study and picture process has been greatly devised by combination method of strength control testing and development control mechanism picture break. Next, simulation of the break, the bull crack, calculation of the region, calculation strength in the simulation crack row mechanism outside of the plastic zone can be produced like in the picture 7.23, especially low cycles, height, improvement, trend control, fatigue test help qualify the condition of the early crack in stagnation, while fracture mechanism testing help qualify the crack growing rate after the intention. This is Victor 7.23. But next, that's the tension accelerator. Fractures combination pressing frame, bolt assemble and a component subject to that thermostat. In the case a pressure frame would be a 0 to maximum tensile loading condition. The joinery has been loaded and the presence loading will be the maximum tensile stress. The bridge and boost thermal compression will have a population that's loading with the mid stress being average temperature. At the time of compression, my material habit as a protection extraction from strike material and the ocean stretch. Bending fixation result in the surface being subject to alternating pressing compression stress in the varying partition with the limiter strength between the tension and compression. The stress are given by Q is MC or I. The M is bending moment, C is the position of the center of section of the outside surface, and A is the area maintained of the initial of the selection. Next, common completely subject is bending figure, golden flat type. Formulas and treat can maximum surface processes such as softening and compression, and the compression stress are then used to calculate figurative compression in the material providing or the orderless properly at the time equipment for the vertebrae in the rotating bending given vertical longer life critical in the low cycle size in compression. Example patient C in the picture 7.24. There is the relation for the development methods covered fiberglass stress in the bending type of test form. This is 7.24 picture. State of life fracture test is gonna person going from the continuous for the circle left to the left suburb. It's experimented and there's a cycle and EG from the upwards of 102 to 106 cycles as a assembly of the flow of the crack a larger can be described by a D per dn. The change of crack related to stick the numbers will be placed. Typical proof is plotted in the picture 7.25 picture as the picture of the rest as per the sample from during of the preparation testing is key. Note because the AK is a percent of the crack lot as the digits crack in the value of the AK change can be performed in 7.7 the non-destructive testing. Fakultas non-destructive testing NDAT and Inspectio Teknik are commonly used in the detect of the value flow and the of the discontinuous or defect in the engineering system, like the table 7.2, the sample and breakdown of the completely operated performance of the 5 most common or used NDT technique. Table 7.3, the population command the NT method. It should be noted that is by meaning summarize all the of the NDT technique used. Table 7.2. Next up, liquid penetration is the further penetration method used to find discriminator that are often to be separate for the solid as a non-porous material. The liquid penetration is expected process in the cell in the figure 7.26 additionally open with the surface of the metal location of the alloy penetration die of the purchase liquid or to the influencer it. Access penetration is moved to the next step by various means such as wiping with cloth like a picture 7.26a or the by washing disposal with water treatment, treating with the emulsifier and the greasing, or removing with a sulfur. This is followed by applying developing agent. This is an agent force the penetration to sink back to discover of the region as the condition. This is picture 7.26. Cognitive particle infection disease, local surface and stop surface discontinuity of the permanent material. Magnet is a particle are applied over the surface either as dry particle or as a wet particle in the liquid variant such as water and oil. The metal is magnet field generally is by using electromagnetic with the magnetic field produced by electric concept various picture whether are used electromagnetic yogurt seen in the picture 7.22 consists of coil founding around a U-shaped core and soft iron unlike the permanent magnet yoke and the electromagnet yoke can be readily switched on and off and the magnet completely applied and remove yoke from the test. Next. In the Adley contact method, the part of special placed within in the adjustment to the electric coil which is apparently a correct flow. In the current, correct is also knowing exactly from the post the Adley and the same will flow in the part resolution of the mechanical induction. Flow is as a correct in the pipe is because it changes the characteristic of the flow of the concrete of, for example, picture like a 7.8, 28, 7.8 picture. A lesson of pipe travel along the length of inspection coil is lesson A minus A. It is apparent of the correct is not present because the flow only is water indicated by a road was not impeded or is symmetrical is section B minus B. However, is the only correct flow is not symmetrical also because it is was impeded passing to the change environment, such as climate change is the essential management of the field that can be detected and measured by properly discovered mentioned. Next, and that's all the presentation I give today. And thank you for watching and have a nice day. Thank you so much. Bye.